These are the examples for Algebra 1B, Credit 4, and we have a combined lesson here, 2 lessons again for the price of 1, 22.2 and 22.3. All right, so what we're going to be taking a look at, first of all, problems 1 and 2. Let's just read the directions and we'll just jump into it. It says Richie is solving the equation, and the equation for our example is x squared minus 18x equals 53. By completing the square, what number should he add to both sides of the equation to complete the square? So to complete the square means to make it a perfect square trinomial. And a perfect square trinomial just means if we were to factor it, it would be the same two factors, like x minus 5 times x minus 5 versus x minus 5 and like x plus 7. Now, we're not going to do the whole process here. The only thing you have to do is that first step and find the number that you would add to both sides of the equation in order to complete the square. And the way you do that is you take the coefficient of x. So the coefficient of x here is negative 18, and you divide that by 2, always 2. Cut it in half, I guess you could say. And that gives us negative 9. So 2 steps. That's the first one. Take the coefficient of x, divide it by 2, and that gives us negative 9. Then you take the negative 9 and square it. And remember, what does negative 9 squared mean? It means negative 9 times negative 9. So when you square a number, you're multiplying it by itself. And so a negative times a negative is a positive. 9 times 9 is 81. So the number that should be added to both sides of the equation is 81. So not too bad there, not too much work. And that's all you got to do for problems 1 and 2. Just come up with that first step if you were going to solve that equation by completing the square. All right, our example for problems 3 and 4, we're going to, it's the same thing, but we're going to do 2 of them. They want to use the discriminant to determine the number of solutions for each quadratic equation. So the discriminant is the part of the quadratic formula, which we're going to be talking about next, that's underneath the radical, and that's actually the b squared minus 4ac. And so b squared minus 4ac, let's go ahead and let's put that over here. And yeah, we should have room here. So if b squared minus 4ac is greater than 0, it's positive in other words, there's 2 solutions, 2 real solutions. If b squared minus 4ac, if that ends up being exactly 0, that means there's 1 solution. And if it's negative, meaning it's less than 0, there are no solutions, no real solutions. All right, so if it's positive, greater than 0, there's 2 solutions. If it's equal to 0, 1 solution, less than 0, no solutions. So let's go ahead and work the discriminant out. So they're asking you for the discriminant, and then based on what the discriminant is, what's the number of solutions, 0, 1, or 2. All right, so we need A, B, and C. A is the coefficient of x squared. There's nothing there, so A is 1. Well, there's nothing written there, so we know it's a 1. B is the coefficient of x, so B is 10. And C is our constant term. C is 24. And let's go ahead and substitute those numbers in. We have b squared, so 10 squared minus 4. Now remember, 4 is just part of the formula. So we have 4 times a, which is 1, times c, which is 24. All right, now following the order of operations, we're going to work that out. So 10 squared, remember what squaring a number means, multiply it by itself. So 10 squared is 10 times 10, which is 100. And then over here, we're going to multiply. Now that's a negative 4. So negative 4 times 1 is negative 4 times 24. And then, so negative 4 times 24 is negative 96. And then 100 minus 96 is positive 4. So our discriminant, write that out there, is 4. So remember, there's 2 parts to the solution. What's the discriminant? And then based on that, how many solutions do we have? Well, note that the discriminant there is 4. And so that is a positive 4. So, which means b squared minus 4ac is greater than 0. It's positive. So that means there are two solutions. Two solutions. And that's it. That's all you have to do there. All right, so let's take a look at one more example with the discriminant. So same idea here. Let's go ahead and find our a, b, and c. A is the coefficient of x squared. There's nothing there, so a is 1. B is the coefficient of x. Now, careful here. That's a -7. So a lot of times students will forget the negative, so make sure you do include the negative if it is negative. And of course, c is positive 30. All right, let's go ahead and substitute those in. We have -7 squared minus 4 times a, which is 1, times c, which is 30. All right, so starting with -7 squared, -7 squared means -7 times -7. A negative times a negative is a positive. 7 times 7 is 49. So positive 49. Then over here, -4 times 1 is -4. And then -4 times 30. Negative times a positive is a negative, and 4 times 30 is 120. Finally, 49 minus 120, we have a positive and a negative, so we subtract the two numbers. 120 minus 49 is 71. The larger number, the 120, is negative, so -71. So our discriminant, so a little messy. Whoop, that's misspelled. Let's try that again. That was messy and misspelled. So discriminant. There we go. Got it. All right. So our discriminant is -71. -71 means the discriminant was less than 0, because less than 0 are your negatives. So that means there are no solutions, 0 solutions to this quadratic equation, 0 real solutions. Now you might notice I said real, but real and imaginary, that's an Algebra 2 topic, so we won't get into that here. All right, so that is what we do with problems 3 and 4. Find the discriminant based on what the discriminant is. Positive 2 solutions as we had here, exactly 0, 1 solution, less than 0 meaning negative, no solutions, which is what we had in our example for number 4. All right, so now let's go ahead and erase all of this. And the last part of this lesson, we're going to be looking at the quadratic formula. And we're going to do 2 examples, even though the last 2 problems, 5 and 6, are, you're going to handle them the same way. But let's go ahead and take a look at how we do this. All right, so this will be our example. We're going to call it for number 5. And let's see here, make sure we've got the right one here, and which I think we do. All right, so we have x squared plus 2x minus 17 equals 0. And what we're going to do, we'll put it, I guess, over here. So here's the quadratic formula. It's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula. So we're going to have it over here. Keep that in mind because we'll be using that once we identify a, b, and c. And so that is our first step, identifying a, b, and c, just like we did with the discriminant. So a is the coefficient of x squared. There's no number written there, so we know that a is 1. B is the coefficient of x, so b is 2. And then c is our constant term, so c is -17. And so now we're going to substitute those numbers into the quadratic formula. So we have x equals -b. So it's -b. So even though b is positive, it becomes negative because of that negative in front of the b. And then plus or minus, again, b, but this time squared. So b squared, so 2 squared. So there we go. Sorry, b squared minus 4ac. So minus 4 times a, which is 1, times c, which is -17. And then lastly, all over 2a. So a is 1, so 2 times 1. All right, so now we're going to kind of do this in a way that hopefully is going to be a little bit less writing. So here we have the negative 2. So we're just going to bring that down. And then now for the radical, I'm just going to kind of work things out up here because that way we don't have to keep rewriting the entire thing. So we're going to follow our order of operations, exponents, then multiply, and then any addition or subtraction. 2 squared, remember 2 squared means take the number 2 and multiply 2 of them. 2 times 2 is 4. And then over here, negative 4 times 1 is negative 4. Negative 4 times 17 is positive 68. In fact, you know what? Let's do it like this. Just realize it's going to get a little bit messy here. So let's just write it down here. So we have 4, and then this will be negative 4, and then times 17. Well, a negative times a negative is a positive, and then 4 times 17 turns out that is 68. And then, of course, in our denominator, 2 times 1 is 2. All right, so now we have to add this up here. 4 plus 68 gives us 72. So we're going to erase that. Well, should we do that? Let's see. Let's just leave that there. Trying to reduce the writing, but we want to have you guys be able to look at the whole thing and see it. So let's go ahead and write that out. It's not too bad, right? All right, so now we have negative 2 plus or minus square root of 72 over 2, and that is our solution. What we need to do now is to see if we can simplify this any further. And what do you mean by simplify it? So what we're going to write over here is our perfect squares up to 100. So let's go ahead and do that. So the square root of 1 is 1. The square root of 4 is 2. And let's go ahead and write these up here. We'll do that really quickly. So just we have this as a reference. Square root of 36 is 6. In fact, let's actually put the rest of these over here. The square root of 49 is 7. 64 is 8. 81 is 9. Square root of 100 is 10. All right, so now what we're going to do is, you might remember your factors 1 to 100 sheet that we were using for factoring in previous lessons. We're going to use that here, but maybe kind of in a slightly different way. And so let's go ahead and we're going to go ahead and share the screen. And what we're going to do is we're going to look at the factors of 72. And 72 actually, it turns out, has a good number of factors. So there's 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Now, we want to see, are any of these perfect squares? Now, we have all of our perfect squares here up to 100. So we can see that, and here's we're looking under the radicals here. So we see 1's a perfect square. We see 4 is a perfect square. We see 9's a perfect square. We got a lot of them here. And also 36 is a perfect square. Now, of all those numbers we circled, what's the largest one? It's the 36. And so that's what we're going to use, 2 times 36, to simplify this radical here. So we have negative 2. In fact, let's just write it up here. 36 and 2. The square root of 36, and we have that over here, is 6. Make sure you guys, actually, let's go ahead and stop sharing so you can see that, okay? And let's go ahead and go back to there we go. All right, so the square root of 36 is 6. And so we have 6 radical 2 over 2. Now, we're almost done. One more step. So what this fraction bar means is we have to divide each term here by 2. And so we have negative 2 divided by 2. Let's see if we can squeeze that down there at the bottom. So negative 2 divided by 2 is negative 1. And then 6 divided by 2 is 3. So our final simplified radical and simplified fraction is negative 1 plus or minus 3 radical 2. All right, so that's our example for number 5. That'll probably be a little bit more like number 5. But again, both these examples we're doing for 5 and 6 will help you with either problem. All right, so now let's go ahead. Again, you can pause. Let's make sure we can see everything there in case you want to pause the video and look at that. So now let's erase this. We're going to leave our formula and all of our perfect squares there. And let's do one more example for problem number 6. Although again, both of these, as we said, will be very similar. All right, so for our next example, we have x squared plus 8x minus 2 equals 0. And so again, to start off, we're going to identify our a, b, and c. So there's nothing there. So a is 1, b is the coefficient of x, b is 8, and then c is negative 2. And again, don't forget if any of these are negative, don't forget to include the negative. Very important. All right, so now let's start substituting. We have negative b. So we have x equals, so b is 8, but it's negative b, so negative 8. And then the square root of b squared, so 8 squared, minus 4 times a, which is 1, times c, which is negative 2, all over 2a. 2 times a is 1, so 2 times 1. And so now let's go ahead and start simplifying here. We start working this out here. So we have negative 8, and then here we have 8 squared, which is 64. Remember, 8 squared means 8 times 8. We're going to take the number 8, multiply 2 of them. And then negative 4 times 1 is negative 4. And negative 4 times negative 2 is positive 8. And of course, in the denominator, 2 times 1 is 2. All right, now over here we have 64 plus 8, which is 72. Oh, wow, that's the same thing we had on the last one. So I guess we'll get to see that again. And so again, we're going to simplify our radical. We're going to look at our factors 1 to 100 sheet, but we've already done that. So let's list out our factors of 72 again. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5, well, not 5, 6 and 12, and then 8 and 9. So now the numbers over here, these numbers that we're taking the square root of that are perfect squares that are on the list are 1, 4, 9, so 1, 4, 9, and then also 36. And as we remember from the last problem, we want the largest of those 4. That's the factor pair we're going to use to simplify that radical. The largest of those is 36. So we have x equals negative 8 plus or minus. We have, let's go ahead and write it here, 36 times 2. The square root of 36 is 6 because 6 times 6 is 36. So we have 6 radical 2 over 2. And then let's see if we can squeeze that in at the bottom. So we have to divide each of these terms by 2. Negative 8 divided by 2 is negative 4. And then here, 6 divided by 2 is 3. And so our final answer, the very bottom of the board there, is x equals negative 4 plus or minus 3 radical 2. All right, so now that takes care of that example. What I want to do, though, since we have the same number under the radical, I think we'll do one more. We'll call it a bonus example. So if you feel like you have a good understanding at this point, you can stop the video. You have everything that you need. We're just going to do another problem where we're not going to get a 72 underneath the radical. And so let's go ahead and maybe we'll have a different number. We had 2 here in the middle. We had 8. So let's try this one here. So let's go ahead and erase this. And let's see, get all of that in. There we go. Okay. All right. So one more. We'll call this a bonus example. And so this is just an example. We'll call this a bonus. And so let's go ahead and take a look at this one. So we have x squared plus 6x minus 3 equals 0. And by the way, one thing you'll notice as you do more of these problems, you're going to learn. It's going to get quicker and quicker each time you go. So what I might even challenge you to do, if you stuck around to watch the bonus example, is maybe even pause the video, and you're not required to, obviously, but if you want to, and try and work this problem out. See if you can solve this, and then we'll work it out, of course, up here as well. So if you pause the video, hopefully you've worked it out. Hopefully you got the right answer, but here's what you're going to do. So again, A is 1 because there's nothing written there. B is positive 6, and C is negative 3. So we have our A, B, and C. And now we have our quadratic formula. We have x equals negative b, so negative 6, because of that negative in front of the b. And then plus or minus b squared minus 4 times a, which is 1, times c, which is negative 3. Remember that 4, of course, is just part of the formula. And then all over 2a, 2 times a, so 2 times 1. All right, so now we're going to be working this out. So we'll bring down that negative 6. And then here we have 6 squared, which means 6 times 6, which is 36. And then negative 4 times 1 is negative 4. And then negative 4 times negative 3. Negative times a negative is a positive. 4 times 3 is 12. So positive 12. And then in our denominator, 2 times 1 is 2. Simplifying what's under the radical, 36 plus 12 is 48. So we get a different number this time. And you can see it can go pretty fast. We're already to the point where we're ready to simplify the radical. So let's go ahead and share our screen and go get the factors of 48 from our factors 1 to 100 sheet. And you can see here 48, there's 48. And that one has 5 pairs of factors. So we got 1 in 48, 2 in 24, 3 in 16, 4 in 12, and then 6 and 8, I believe is, yeah, that is it. So now, which of these factors are perfect squares? Well, of course, 1 is. Let's see what else. 4 is, and 16 is, and I think that's everything. All right, so now, of those 3, 1, 4, and 16, what's the largest? Well, obviously, 16. So the factor pair we're going to use to simplify that radical is 16 and 3. So just write that up here. The square root of 16 is over here is 4, and that's because 4 times 4 is 16. So we have negative 6 plus or minus square root of 16 is 4, radical 3 over 2. And now remember, for our final step, oh, didn't stop sharing. There we go. All right, so let's catch up in case that was too small to see. Again, 16 and 3 was the pair we used, and the square root of 16 was 4, because 4 times 4 is 16. All right, now dividing these out, negative 6 divided by 2 is negative 3. And then 4 divided by 2 is 2. And so our final answer here is x equals negative 3 plus or minus 2 radical 3. All right, so that is it for lessons, I should say, 22.2 and 22.3. We had a kind of a combined lesson here. And again, pause, rewind the videos, make sure you've got a good understanding. We'll step out of the way just in case you want to pause that and study that. But again, with more practice, you're going to get better and better at solving quadratic equations and using the quadratic formula. So again, as always, do your best, watch the videos. Again, if you need to, ask questions, and good luck with the work. And until the next video, take care and God bless.